we can use de Moivre's theorem to write cos 5a or sine 5a in powers of cos a or sine a, or sometimes a mixture of the two. Let's see how we do this with an example. If we start with sine 5 theta, and we want to write this as a power series in sine theta, the first thing that we remember is de Moivre's theorem. This tells us that cos 5 theta plus I sine 5 theta is equal to cos theta plus I sine theta, all raised to the power 5. Well, we can use Pascal's triangle to work this out. It's a long line, so I'll start right over here. Cos to the power 5 theta plus 5 cos to the power 4 theta, I don't want the theta up there, times I sine theta, plus the next number is 10 cos cubed theta, I sine theta squared, plus 10 cos squared theta, I sine theta cubed, plus 5 cos theta, I sine theta to the 4, plus I sine theta to the 5. We're looking for sine 5 theta. Well, sine 5 theta is the imaginary part of this number. So it must be equal to the imaginary part of this rather long number here. So the next thing we're going to do is to equate imaginary parts. But if we do that, we get sine 5 theta. The first one is here, 5 cos to the power 4 theta sine theta. The I indicates it's the imaginary part. I was about to write plus, which I don't think I want. This part here, the I squared becomes minus 1, that's real. This one, the I cubed, becomes minus I. So my imaginary part here is minus 10 cos squared sine cubed. Moving on to the next bit, I to the power 4 is plus 1, so that's real. I to the power 5 is plus I, so the imaginary part here is plus sine to the power 5 theta. We're supposed to be writing this as a power series in sine theta, and I've got a whole lot of cosines. Fortunately, all the cosines are to an even power. We can think of cos squared theta as 1 minus sine squared theta. So if that's cos squared theta, if I square it, I get cos to the 4. So what I've written there is cos squared is cos to the 4. I need to multiply by sine theta. Minus 10. Cos squared is 1 minus sine squared times sine cubed theta plus sine to the power 5 theta. So we're nearly there. Clearing the brackets, we're going to get, well, perhaps I ought to expand the first one first. 5 times 1 minus 2 sine squared theta plus sine to the 4 theta times sine theta. minus, okay, I'll clear this bracket while I do it, 10 sine cubed theta plus 10 sine to the power 5 theta. And the last term is just plus sine to the power 5 theta. What have we got now? We have 5 sine theta. Then we have 5 times minus 2 is minus 10 sine cubed theta. Minus 10 sine cubed theta minus another 10 sine cubed theta is minus 20 sine cubed theta. And the last term in the bracket, 5 times sine to the 4 times sine is 5 sine to the power 5, plus 10 sine to the 5 is 15, plus 1 is 16. So that is plus 16 sine to the power 5 theta. And now we have written sine 5 theta as a power series in sine theta. It doesn't work quite like this if we try to do the same thing with sine 4 theta. So let's see what happens now if we work with sine 4 theta. Doing the same thing, we would start off with cos 4 theta plus I sine 4 theta is, using de Moivre's theorem, cos theta plus I sine theta to the power 4. Expanding that gives me cos to the power 4 theta. Pascal's triangle goes 1, 4, 6, 4, 1, plus 4 cos cubed theta I sine theta, plus 6 cos squared theta I sine theta squared, plus 4 cos theta I sine theta cubed, plus I sine theta, all raised to the power 4. So far, so good. We're looking for sine 4 theta, that is the imaginary part. The imaginary part is here and here. Only 2 places. This is real. I squared is minus 1, so that is real. I to the power 4 is plus 1, so that is real. So if we now equate imaginary parts, let's make the P look a little nicer. We will get that sine 4 theta is, the first one is 4 cos cubed theta sine theta. And the next term, which is imaginary, is, it's going to be minus because it's I cubed 4 cos theta sine cubed theta. So there are my 2 terms, I times 4 cos cubed sine, and this one is I cubed, which is minus I, giving us minus 4 sine cos sine cubed. We can't write this now as a power series in sine theta because we have an odd power of cosine. I can't change all my cosines into sines using cos squared is 1 minus sine squared. It doesn't work the same way. So in this instance, what we can do, we can express sine 4 theta divided by cos theta in terms of sine theta only. So if I divide both sides by cos theta, I get 4 cos squared theta sine theta minus 4 sine cubed theta. That's equal to 4. Cos squared is 1 minus sine squared theta. Sine theta minus 4 sine cubed theta. And this is then equal to, first bit is 4 sine theta. And the next bit is minus 4 sine cubed. Minus 4 sine cubed is minus 8 sine cubed theta. So I cannot express sine 4 theta as a power series of sine theta, but I can express sine 4 theta over cos theta as a power series in sine theta.